Hello, good morning, everybody. This is Dr. Paul here again. This is in continuation to my presentation on climate change studies. Today I am going to talk about my second lecture that is going to cover on a very specific simulation model, that is FACE technology, that is free air CO2 enrichment technology, and free air temperature enrichment technology, and both phase and fate technology. And finally I am going to cover also ozone enrichment system, that is free air CO2 ozone enrichment technology or free air ozone enrichment technology. As I have told in my earlier presentation that on Global Environment Day I am going to cover around 8 or 9 technologies, that is our indigenous technologies, and how those technologies are impacting crop research and developing new varieties. In my first lecture I have covered open top chamber, that is the OTC technology. Now previous that I have talked about plant growth chambers. Plant growth chamber is a closed system, open top chamber is a semi-closed system, and the phase system that what we are talking about is completely experiment and research done conducted in open atmosphere. The basic objective of climate change research, it is as long as you are operating your system or carrying out your research experiment in open atmosphere, it is more realistic and more scientific, and that is the approach that is taken in developing free air CO2 enrichment system. What is free air CO2 enrichment system? Let's come back to the system first. Free air CO2 enrichment system is nothing but in a confined area. It can be 4 meter, 5 meter, 6 meter or 7 meter. You can go up to 15 meter or more area that is encircled with a releasing system, CO2 releasing system, and you are enriching the CO2 level above ambient level, and you are trying to maintain and achieve that particular CO2 inside that particular area. Now fundamentally how the structure would be. Now the question is, if in open atmosphere, if you see that in open atmosphere your CO2 level is around 380 to 400 ppm. Now in open atmosphere you are trying to make a circle, and in that either it can be a benzene structure, hexagonal structure, or it can be octagonal structure, or it can be a circular structure made of PVC pipe or SS or GI with a releasing option at the front direction, at the center direction, and there should be a complete releasing option facilities. It's a fully automatic releasing option facilities where your CO2 tank and other things are connected, and you are releasing CO2 in a precise manner, and you are growing the crops inside the chamber throughout the crop season. So this is basically a simulation chamber in open atmosphere. Now the question is, how do you do that? It is very, very difficult to have a simulated environment in open atmosphere where you are enriching CO2 level up to 600 to 650 ppm in that particular area. So your CO2 releasing has to be in such a way that at any given point in time there must be homogeneity is maintained, that particular CO2 level is maintained throughout the crop season. Now in open atmosphere there are few things, fundamental things, the physiological parameters and environmental parameters you need to understand. You have temperature throughout the day, you have temperature variation, you have wind speed, wind direction, moisture level. So these are all variables. It is not a very static kind of environment. So now if you want to have a system developed, and if you are drawing any mathematical modeling or any simulation modeling based on all those variable factors, you need to see the hardware and the software has been developed such a way so at any given point in time your CO2 level is maintained inside that particular area. So I'm going to talk about little more about how the logic control has been developed in order to achieve that particular atmosphere. Now coming back to the system development, as I have told you, you can have a hexagonal structure with 6 arms. Let's say if you are developing 6 meter or 8 meter ring, you can have 7 feet or 8 feet pipe of 6 to 8 inch dia with a small nozzles or more small micro holes for CO2 releasing. So there will be 6 arms that can be mounted above ground with height adjustment option, and in each pipe you can have air blowing option, or fan can be mounted at the two end of each pipe. That means altogether 12 fan, high speed fan can be mounted, and CO2 connection can be injected in front of those fans. This is one way of doing it if you are using PVC pipe. Now it is very important the selection of material, because CO2 should not react with other materials. You can use also GI pipe or SS pipe with a releasing nozzle can be fitted at the front and with height adjustment option. Now this is the structural part. The height it can have from ground to around 10 feet or 15 feet height you can take in different height. You can have as per the crop grows, you can lift those pipe into that particular height so that for CO2 releasing, so CO2 can be exposed to canopy level. We can use that. As I have told you again, there are 3 things you can use, either PVC pipe, GI pipe, SS pipe, and you can use Teflon or polyurethane tubes, that is the PO tube for releasing, and the connectors and other things for so that there is no leakage at all. Now this is the hardware part. Now you can take a CO2 line of each ring into the control room. In control room there will be a provision for a CO2 tank with a vaporizer or CO2 cylinder with a manifold, and there is a mixing chamber, either it can be compressor or in a mixing tank, so that the concentrated CO2 can be mixed and then discharged with high pressure into those rings. And one more important parameter is there should be a manifold. Like each arm you need to control, that each arm will be used for controlling the CO2 level, the direction. Now coming back to the hardware part, as I have told you, wind speed and wind direction plays an important role in controlling the CO2 level and maintaining the direction and maintaining the homogeneity or uniformity of CO2 inside the chamber. So what we are doing we are taking one anemometer. In anemometer you have wind speed and wind direction sensor, and it can be mounted at the center at above 7 feet or 10 feet height. So you can take out the output signal of wind speed and wind direction sensor for controlling purpose. I'll come back afterwards how you are controlling the logic control. Now coming back, in each ring there are provision for monitoring the humidity. You have the humidity monitoring sensor. You can have soil moisture sensor, soil temperature sensor, and also infrared based gas analyzer that can be mounted directly at the center of the ring, or it can be housed at the control room. Now the question is, if you are directly mounting an analyzer at the center of the ring, it should be housed properly, or you can take a sample tube and you can keep also the analyzer inside the control room, and you can pull the air sample from the center of the ring to the analyzer, and each analyzer is having also 4 to 20 milliampere output option. That option can be taken into the control system. Now coming back, this is your structural designing is done. First of all, we need to know what kind of crops we are growing. Based on that, we can design or define the system or structural designing part. How much height or what would be the length, total crop area can be decided. Based on that, you can develop the ring structure, and based on the CO2 level, you can have CO2 line that is been laying out up to the control room, and you can have the CO2 tank, and also compressor, the mixing chamber can be done automatically. Now this is a one ring. As I have told you that if you want to work on only 3-year CO2 enrichment facilities, only CO2 enrichment you are looking for, you need to have minimum 2 phase ring. That is the basic thing what I am talking about. One is for ambient. You can develop a dummy kind of a prototype, a similar kind of simulated environment. You can create it without releasing the CO2 option, and you can take this as a reference, and this is the elevated CO2 one. Elevated CO2 when you are working on above ambient 500, 600, 650 ppm. So you can carry out your experiment, but if you want to have better result, you can have one more ring. That one ring you can use it for 500 to 550 ppm, and another ring you can use it for 600 to 650 ppm. So while you are carrying out your experiment, your at least 3 set of experiment is ready for a particular crop that is to be grown. Now the second part is the controlling part. As I have told you, developing the hardware, the physiological control part is very important. The physiological control is a very critical component that precisely controlling and monitoring the CO2 level inside the chamber. It is going to make you starting from the CO2 release to CO2 control, and the existing CO2 level what you have and what it is going to achieve. So up to that precision you need to make sure that is your hardware and software has been designed such a way. To do that, I have taken all the signal output option that I have told you, that is anemometer, wind speed, the factors. As I have told you again, for developing the software you need to have some inputs which to be applied in your PLC controlling system. The inputs are anemometer for wind speed and wind direction, your analyzer, it is infrared based gas analyzer, 0 to 3000 ppm. It is directly online, real time, giving the CO2 level. So you can take out the 4 to 20 milliampere output option. You have humidity, you have soil moisture, you have soil temperature, and also power, that is for the real time monitoring for all those, what is the humidity level, what is the temperature level, what is the soil moisture level. Now your system is ready. Let's say if you are operating three systems together, one is the ambient, another is one phase ring, that is the free air CO2 enrichment system of 600 ppm, another ring is 650 or 700 ppm. Now in computer screen you can set your parameter, what is the level of CO2 you need it, how much time you want to work, and based on that, once your system is developed, you can operate this system in a continuous manner. There is no need of any human interference. It will be automatically CO2 release, control, data logging, everything can be done. In my previous presentation on open top chamber technology, I have explained that the logic control will remain same. Let's say hypothetically, if you want to maintain CO2 level 600 ppm, the role of a analyzer is to check the existing CO2 level. If it is lower than the set limit, it is going to release CO2, and once it is achieved, because it is going to operate the solenoid and the solenoid is connected to the CO2 tank, automatically CO2 will be released, and it is going to release till it achieves your target CO2 level, and it is going to again stop supply of CO2 once it is attaining the CO2 level. Again it is, once it is coming below, again it is going to operate. Like that this system is going to operate. The role of wind speed, wind direction, this is for arm control. As I have told you, we are going to use close to 12 solenoid valve which is going to control each arm, and that arm will be controlled based on the wind speed, wind direction, which direction wind is blowing. Now the question is, if you have anemometer, if let's say if your wind is blowing from north to south, so your CO2 will be blown from that direction. So immediately your software should be made such a way you can give a threshold limit of anemometer, let's say 6 meter per second. If beyond that your wind speed goes up, your solenoid will be off, means CO2 release will be stopped. Once your wind speed comes below again 6 meter per second, CO2 release will be there, and the other arm will be open, like in which direction air is not blowing. And in normal conditions, from all 6 arms CO2 can be released, and in a special case, if your wind speed is much higher than the normal, your CO2 supply to be stopped. This kind of very critical logic control coding that what you are using in terms of developing this software. Apart from this thing, we also give the complete data logging system. Whatever parameters you are going to control and monitor, its complete data logging to be stored inside the system in a Excel form. Now I told you in my previous presentation that data logging, the wiring, you can have wired or wireless communication facilities to bring the system. You can have user friendly app developed with different kind of password facilities. You can create it, and the wireless communication or Wi-Fi communication is much better compared to wired system, even though system is little expensive because it's much more automation that has been done. So you can run the system. This is all about the free air CO2 enrichment system. Free air CO2 enrichment system is globally used in many countries. US, you name any agricultural research institute, Brookhaven National Laboratory, UK, Germany, France, South Korea, Israel, even in Pakistan. So University of Faisalabad, they have developed a big system for us. Initially they have requested us to bid for this thing. We have submitted the proposal, but at the time of placing the order, there are some issues. They want us to open one office in Dubai. It's close to $1 million order. Then since we do not have much good relations, India and Pakistan, we told it is not possible for us to do all kind of exercise, opening office in Dubai and do this exercise. The logistic problem in developing the system. We requested them to write to Ministry of Home, Government of India. So they have refused to do that because we don't like to do any work with Pakistan. So at least keeping some honesty, transparency. So we have rejected this proposal. That is a separate thing altogether. And we have not done this job. I really do not know whether they have executed this job afterwards or not. So we have straight away rejected. There is nothing. It should be a transparent and fair manner. If you want to do it, we are ready to do it. You need to give all kind of protection, security, right to Pakistan government should write to India government. This is the company, they are going to do this job. You give the permission, required permission. They failed to do it. So we do not like to do this job in backdoor, and we have refused to do that. Beyond that, we have done very, very critical systems in India. I'm going to talk presentation. I'm going to talk about only the phase system we have done at NBRI, National Botanical Research Institute. We have done for last 10 years, we have developed close to 11 rings, phase, fate, ozone, combined effect, synergic effect, both temperature and CO2. So I'm going to talk about in my next presentation, free air temperature enrichment. There I'll talk about what are the jobs we have done at NBRI. Beyond that, we have done at ICRISAT, phase system for them. It's an international research institute located in Hyderabad. And these systems are still, we are supporting this system, and they are working on legumes. We have also worked at Dr. M.S. Swaminathan Research Foundation, Chennai. Around 8 or 9 years back, we have developed this system. Dr. Swaminathan, he came personally and inaugurated the system. He is very happy to see the system, and he thanked us. That is kind of Indian company, indigenously have developed such a critical system. He blessed us. We cherish his blessing till date, and every day we pray that the man like Swaminathan is appreciating us. It means a lot for us. This kind of encouragement is very essential sometimes to do better things in life. Beyond that, we have done similar kind of system at IRI. IRI, we have developed the entire climate change research studies is done by us. It is almost, we have developed the temperature gradient tunnel for their NRL, Agricultural Physics Department. We have developed the FATE system. Initially, we have Plant Physiology Department. We have worked on OTC whole instrumentation. We have developed phase ring for them. We have developed for ozone CO2 ring for them. So we had a long association with them at IRI, Indian Agriculture Research Institute, for many years. And there are n number of research paper that is coming out from those projects. So those are various phase system that we have developed. We have developed the first phase ring. It is needless to say that is ISBT. It's a CSI Research Institute at Himachal Pradesh. There we have developed 6 phase and fate ring for them. Dr. Ahuja, when he was director, and then he became DG. So we had a very close association, a lot of interaction. Dr. Sanjay Kumar, he is now the present director. We have worked very, very closely with them. So it's a very pleasing moment. Like, we are so happy to work with so many good scientists, energetic scientists. They really want to do something for climate change studies. So it is needless to say that this phase technology is not a very common system that anybody can afford to develop those kind of system. It's expensive system. If you want to work on phase technologies, you need to have a budget close to 1 year for 3 years project if you want to develop 2 rings, and the CO2 consumption cost is much higher because you are exposing those environment into high CO2 level, so that you have to have allocated budget or funding for that. For system development, okay, once you develop the system, you can have 6, 7 or 8 years. You can be rest assured those systems are going to work. But what about the CO2 consumption cost, the maintenance cost and other things? That has to be taken care by the institute. As I have told again in my various presentation, any simulation model or any simulation chamber on climate change studies research, it gives enormous opportunity for various departments to come forward and contribute their research credential over there. So it's not a job, a single man job. It has to be from different departments like plant physiology, biochemistry, microbiology, agronomy, horticulture, soil microbiologist, biotechnologist, all can come together. And once you are growing plants inside the elevated chambers or phase ring, whatever things that is changing or occurring, that can be studied, and show that a good publication and a good variety can be developed, and those varieties can give you a good germplasm for your future need to mitigate the climatic conditions. Again, a biological science has to be taken not into in a single direction. It has got multi-dimensional field, and basically environmental research also a field where contribution should come from all stakes, so that we can do much better and much better research can be conducted. So finally, today I am going to only restrict to free air CO2 enrichment. In my third presentation, I am going to talk about free air temperature enrichment technology, how the temperature enrichment system can be developed and a homogeneous temperature can be inbuilt in the system along with the CO2 part. Because it is very important to understand the correlation between CO2 and temperature. You cannot work only on CO2 until or unless you see the temperature aspect while developing those phase and fate system. So it should be CO2 and temperature together, not independently. So again, for the learners, it is very important to know the application part, what they can do it. It is not very important to know the hardware, the software, the controlling part. It's a basically engineering job. It's a very theoretical concept that is taken to develop a model, and this is a functional model. You need not get into the complexity, how this is done, how the logic control is done. This is the job of us to do it, not for you. Your objective is to the confined area where you want to carry out your experiment, and what are the parameters you want to concentrate. And it might be anything. You can want to take the photosynthesis part, flowering, biomass. So what are the biochemical changes, biochemistry? There are many aspects can be studies, plastid, stomata, index, many things like and final objective is to make sure in those kind of elevated conditions the best variety, the adaptive variety, you can select it. That is the screening part, you can do it. And finally your ultimate product is get a good adaptive germplasm for your future need. Again, thank you very much for hearing my small talk. This is a very kind of ready-made presentation what I am giving. It is not prepared, it is my experience for many years what I have given in this particular field. At the beginning it is for me to hard to learn all those things, because I am also from a background, I understand biology a little bit. I am basically a microbiologist. I did my PhD. I worked on nitrogen fixing bacteria, understanding this instrumentation part, understanding simulation and modeling, developing mathematical model, make it a technology, make it workable. This is a long journey. I had a lot of communication with different global research institute. I've got their publication, gone through it. It's a long journey altogether. I'm not getting into that part. What I'm trying to tell you now, that those technologies are available in India. Once upon a time in India, to develop a phase system, scientists have spent 5 crores, 6 crores to develop one project, because the technology, in the name of technology, we have spent so much money. The NPL, National Physical Laboratory, IRI, those people have taken those technology to develop kind of a system. Now, again coming back, now we have indigenously developed those technology. We are giving 1/5 of their price, such kind of technology, and we are giving support for 2 years, 3 years with the cost. Indirectly, we have saved so much revenue for government of India, and we are proud to tell you. People talk about the contribution part. The contribution, it can be also estimated in various ways. What kind of contribution we are doing it. I'm talking about only one project. If you are importing those projects, you are spending 4-5 crores rupees. Imagine we are giving the same system for 1 year, means you are saving how much? 4 crores, and convert into US dollar. So like that in India, if your 10, 12, 15 system is in operational, what is the total revenue you have saved for government of India? And we are approachable to the scientists, scientific community, and those data are valid data. So there is no need of importing those technology. The many technologies now available in India with much more lower affordable price. So imagine a situation, if you want to buy a simple machine from Lycor US for CO2 and CO2 analysis system from Lycor, CO2 and H2O. it is costing close to 30-40 lakhs rupees. In that price, we are giving a complete phase system, including analyzer, hardware, software, CO2 tank, control room, logic control, anemometer, all the system. We can give you 20 parameters, 3 years support, those kind of stuff. Whenever you are getting one simple analyzer for 30-40 lakhs rupees. So I'm not comparing over here that what are the benefits of those systems, but now those technologies are available in India. You can have Indian companies to be encouraged to do such kind of activities, so that the entrepreneurship, we can be encouraged to do various research work and we can support them. So this is a simple example that what I have given to you. It is up to you to decide that what benefits that what we are getting